I am working on DynamoRIO, which is an external project that is being led by Google right now. Two other people working out with me this semester, Hugh and Toshi. So what we've done so far is there's another person that's like doing it just for fun, so he's kind of poking around me, helping get his firing set up and stuff. There's a C front end that we're working on because we're replacing Perl to Scroll Bad. That should be pushed today or tomorrow. I just finished the test suite, everything passed, it was good. The Wix is like an installer package that you can use for Windows and stuff. So Key's been working on that, and he had a few bugs with it, and they should be cleared up now. There are a bunch of other bugs that we've been hitting with just general DynamoRIO stuff. We met with the lead author actually in person rather than a video call as usual yesterday. We started doing some of those. Some of them involve like the test suite or testing for a system call that Windows 8 is like moving around. So if you remember some of the other ones were? So the bugs we were talking about yesterday, we gotta get fixed. What? Yeah, no, there was like 4 or 5, and they're like breaking things. Yeah, those should be fixed very soon because they're pretty simple fixes. We have a format that we're going to be using for the dark deep set output format. So right now it was this giant text file with a bunch of numbers. It's completely human illegible, which was the reason for my summer project 2 years ago to parse that. But currently it's like the parsing is really slow because it's text. So we're going to switch to binary, and that should help like load everything a lot faster and keep like things simple. Because people aren't going to read the text anyways, it's too long. It's like 3 gigabyte text file. Probably get inspiration from that. Yeah, the one thing that Mark, the new person who's just doing this for fun, kind of hanging out, seeing what's going on, he was going to work on just adding a little print statement into like to Docker memory. So a lot of problems that people have in Docker memory and data structures, for example, result from the AV installing its own hooks into some of the functions. DynamoRIO is also trying to hook. So those kind of collide, and that causes problems because things don't work anymore. So we're going to add a statement in there, or like a function, that prints out all the modules that are currently loaded into the application, and DynamoRIO or Docker memory fails to like resolve that stuff. So that way, if it's like, oh hey look, I can see that Avast or like Macafees currently loaded this application. There's also a message there that says you should disable your AV and see if that fixes your problem, because that usually does. And now that like most of the stuff is out of the way, or about to finish up, we're gonna try finishing up actually implementing the writer for the doc cube set that we're trying to implement. So one thing that I know, like most people know, most people here probably use Docker memory for data structures or Docker or heard of it before, but nobody really knows what DynamoRIO is. So DynamoRIO is a dynamic binary instrumentation system, and nobody knows what those words mean either. So I'm going to do a quick little demo, kind of like show you what one of the things you can kind of do with DynamoRIO, which is what Docker memory is built on. Let me take the picture. That big enough. Okay. All right. So, okay. We have this program, which is a serial check program. Say, for example, like this is just a full program, but say, for example, this is a snippet of some larger program we have. And it takes in a name or a username or whatever, and a serial key. And if it does some computation, and then if it matches, then you get to use the program, or you unlock the program, you register the program, or whatever you want. So there's this validate function down here that takes in your name and the password you give it, does some computation like I said, and it compares to see if what it calculated is actually what you inputted, which is how most programs actually do this stuff. They have some like computation or like key that you can usually try to calculate yourself, or look up the program and reverse it and try to figure it out. This one is pretty simple to figure out, so you can just reverse it yourself and then just like write it. But say for example, if this was a couple 100,000 lines long, or like really obfuscated, it had like X-doors and rotates and like shit like that, and you just didn't want to look at it, you're like, no, let's not do that. So you can use DynamoRIO to extract the password for any given name byte by byte. So we're going to use what's called a side channel. So a side channel is not a direct attack on a program, but like a side attack. So you're attacking something that's kind of just like a side effect. So this is used like a lot with cryptography, where, say for example, you have an SD card that is like encrypted. So you can actually perform power analysis on how much power the SD card is drawing while you're trying to attempt to decrypt your data, and you can extract the entire private key bit by bit by looking at the power analysis of the SD card. So all it's easy. And that's kind of related to this. So rather than using power analysis, because this is a full machine, we're going to use instruction counts. So back at here, there's some for loops, right? But the for loop stops, like it's based, like the comparison here is based on the length of your data. And not just the length of your data, the length of valid data. So you're going to stop early if you're wrong, and if you get a character right, you're going to do more instructions. So we can use DynamoRIO. So you have DR run, your client, which is a lib instruction count, and then the program name is serial check. And I pass it some arguments. So that's just a usage thing, capacitive serial, so we give it like A, for example. You can see it tells me how the instruction is executed. And if I try like B or C, it's the same. If I try capital A, for example, 9627. There's a difference of about 100 instructions there. So if we were to change this instead to a for loop that I wrote, so I just tried every capital letter alphabet, because that's what the serial is restricted to in this case. And see, it prints out the instruction count for every single one of these. So we just sort that. Cool. So it looks like T is probably the next letter. All the other ones were wrong, so the for loop stopped prematurely before it exited. But with the T, that was not the right one, so the for loop did another iteration, so we got some extra instructions. Where? So the second rank. Where's the bubble? Right above. I'll fluctuate a little bit. Actually, don't even. Also, so you gotta run it. Okay, so now E is the same. It depends on the run. Probably like for cache stuff. Now X is big. As you can see, I can just sort it. I'm sorting it by that instruction count column, and we keep going letter by letter. Now it's A. Oh yeah, so the last letter is a little different. I don't actually know why. The last letter is actually the only one that's like small. The rest are all the same size, which is really weird. Now, last letter there. Program normally. Success. And if I take off a character, 2 characters, 3 characters, so using that simple program, this is the client for DynamoRIO, and the part they care about is event basic block right here. So this function registers a callback with DynamoRIO. And a callback is just something that at a certain point calls back to whatever function you give it. So in this case, it's this function which is being called back to. And what this function does is it uses DynamoRIO to look into the program, and every basic block, this function is going to be called. And it's going to count the number of instructions that are in that basic block. And the basic block you can think of as just like a logical chunk of code. Precise definition, we'll just ignore it. So it counts each instruction in the basic block, and it just does that while the program executes. And it's just going to keep doing that until the program ends, and it's going to give you that instruction count at the very end. And that's what we're using here to extract the serial key or whatever username you kind of feel like. Yes. Exactly what I did. Here, there was a challenge, or a set of challenges by FireEye Labs Advanced Reverse Engineering team. Those were reverse engineering challenges that they gave out. And this is one that a lot of people, including myself, got stuck on. And Marcus, who's an RPI sec, he's the president, he solved it using this method, or at least part of it using this method. And as like, if you look at the other like write-ups for this, they're like REing all these like rotates and like XORs and like all this other crazy shit that nobody wants to do. But he just stuck it in to see counted. This is the argument count. But scroll down right here. Oh, here's a picture. We did exactly what we did. We just did. We tried to just brute force each one. So we got L, 1, and then next page, he fills it out a little bit more. And then the flag and the account was the email to get to the next challenge. So using this simple technique that we just did, he was able to extract this ridiculous thing. And in this case, the function that does this computation that he was like not trying to reverse by hand actually doesn't even open in like our like the disassembler that we usually use. It says this function is too big. If you actually want to look at it, go modify your setting because it was that ugly. So thank you, Derek Herding and Chin Zhao, who were the primary authors at Google on DynamoRIO and Dr. Memory, like those sub-projects right now. Thank you to President Goldschmidt for supporting me, for having us all here, Sean Sullivan for that big donation, and for all you guys for being here listening to me talk rant about system level stuff. Any questions about DynamoRIO, Dr. Memory, implementation, side channels, RCOS, security? Yeah?
Is that the Lab 1A source code?
What?
Is that the Lab 1A source code that you guys created for?
No. I don't think so. I wrote that last night, or this morning at like 5. Yeah.
Yeah, so I didn't quite understand what you were meaning about that callback thing.
Okay, yeah. So like I said, a callback is something you can register with instrumentation engines. So different points, like instruction level callbacks, basic block level callbacks, functions, system calls, and basically the instrumenter, like DynamoRIO in this case, is just going to loop through all of the ones that are registered and call them either before or after like one of those things, like any event. So if you have some function say, I want to get like an instruction trace of this program, then you can register a before basic block callback with DynamoRIO, and then inside your function, you can just use DynamoRIO to print out what all of the instructions in the basic block is being executed. Or you can say, for example, print out like register states that certain like instructions or basic blocks or whatever, arguments and functions, things like that. That is your question.